Hello and welcome to Amateur Radio Topics. I'm Kevin, VK6LW Whiskey, and in this episode I'd like to talk a little bit about designing and constructing your own wire antennas. But before we do that, let's think about, first of all, what the most important aspect of your station is. Whether it's on receive or transmit, it's always the antenna. And yeah, sure, you can go and buy a beam, you can buy vertical, you can even buy a wire antenna. But it's a lot more fun to build your own antennas, and it's a lot more cost effective as well. And you've got more options in the design. So many years ago, when I first started building wire antennas, probably 50 years ago to be exact, quite a while, the options were you'd look in a magazine, or you'd find the ARRL handbook, or you'd have the RSGB Radcom handbook or whatever. And you'd find something, you'd probably put up a half-wave dipole or a quarter-wave vertical or something, and you get the thing going, and you would have maybe reasonable SWR on there, but you didn't know much else. You got on the air and you tried it out, and you might have to do a little bit of cut and try with the dimensions. You might have had some restricted space. You might have had to bend it around to fit it into the yard space or the garden space available. But generally speaking, if you could put a piece of wire up on the HF bands, get it up in the clear, it was going to work. But you were never really quite sure how it was working, or why it would work well, or perhaps on other occasions why it worked so badly. There wasn't too much literature available at the time about what the parameters of that antenna may have, particularly if it was a compromised antenna, particularly if it didn't fit quite into the cookie cutter scheme of what may have been in the handbook or the manual that you were following. And so consequently, you talk to other guys, you talk to other radio amateurs, and you say, well, what antenna have you got? And they say, well, I've got a 3-element beam, I've got a cubical quad, I've got a quarter wave vertical, I've got a half wave dipole, whatever. They would have a range of antennas, and if they're getting good results with these antennas, they say, well, look, this is a really good antenna, and you might go and then try and duplicate that antenna. So moving on a little bit, as you became more experienced and you tried a range of antennas, you normally tended to find one that worked well at your location. And the location is actually quite important, because if you've got good ground conductivity, you will probably have more success with vertical antennas. If you've got very poor ground conductivity, if you live on top of a hill and you've got rocky ground and whatever, then sometimes a vertical is not quite as good. It just depends. And also there can be other factors involved. But generally speaking, you would work on the principle of, well, we'll try a few of these antennas, see which one works the best, get on the air, test it out, see what the signals are like, and go from there. So moving forward to where we are right now, in terms of the tools that are available to us to build and test antennas, we're a little bit better off. There's a program, and you may have heard of this program, called EasyNEC, and it's a very good program. I've been using this program now for probably about 20 years. So back in those days, the program didn't quite have the features that it's got now, but it was quite adequate for designing basic antennas. And this program really was a little bit of a revelation, because it meant that you could design an antenna on the computer, and it would give you an indication of not only the SWR, but it would give you an indication of the azimuth pattern. It would give you an indication of the elevation pattern, the angle of radiation, all the things you really would like to know. And certainly you could then also program in the type of ground conductivity that you had. And that would also help as well. It's not necessarily going to predict perfectly how your antenna will work, but it's a very good guide, and it can save an awful lot of time. And then from there, you can obviously develop other antennas, and you can test out ideas. You think, well, I might try this idea, and I'll see how that goes. So EasyNEC has made a huge difference. I can remember before that building antennas and spending an awful lot of time cutting and trying and messing around, and at the end of it, still not being entirely sure exactly how that antenna might be working, other than by getting on the air, doing some front to back ratios if it was a beam, doing a test with a local, see what the signal was like, long distance stations, low angle radiation, high angle radiation. Yes, so there were certain antennas, though, that stood out that worked. I mean, there was obviously, if you were able to construct a 3-element beam or a 4-element beam and you followed the formula in the manuals, it was going to work pretty well. If you could construct a 2-element quad on any given band, it was going to work very well. In fact, the quad is probably a standout as one of the most forgiving antennas you can build. You can get away with quite a bit with the quad. It's a very low Q antenna, whereas some beam antennas, particularly if they're close space beams, you've got to be quite careful with the dimensions. So, but I found once I gravitated towards easy NEC, I was spending less time with cut and try. I was spending less time messing around trying to get the best match, because I already had virtually the best match by just following the program and cutting to the correct dimensions. So, and there's another aspect about this as well that shouldn't be confused with antenna performance and the SWR. The SWR really hasn't got anything to do with the antenna performance as such, other than the fact that you need to be able to transfer the power from your transmitter to the antenna. And to do that, you need to have a decent match. And so consequently, if you've got a good match, you'll have a 1-to-1 SWR. If you don't have a good match, you can use a tuner or matching device to create that match between your transmitter and the antenna. And this is where people sometimes get a bit confused. I think they've got a very low SWR. The antenna must be working well. You see this all the time. People say, my SWR is fantastic. Okay, that's great. But what is the radiation pattern like? What is the azimuth pattern like? What is the elevation of radiation? Is that a low angle of radiation? Do you want to work DX? If you want to work DX, you need an elevation as low as you can really get it with an antenna, whether it's a dipole or a beam. It's really important to understand what you're really looking for. If you've got an antenna and you've got very good radiation pattern and you don't have a match, you can always match it. But if you've got an antenna that's a fantastic match, you can't change the parameters of the antenna in terms of the pattern and the elevation angle, which is very important. So there are things to think about. We can talk about SWR in another podcast. It's another story altogether. But the obsession with SWR doesn't necessarily, it's not necessarily healthy for a discussion about what makes a good antenna. You find this when you model with easy NEC that the SWR and the match makes no difference to the pattern of the antenna whatsoever. But obviously in real life, you need to be able to match that antenna to your transmitter. So there's this this is an important aspect to remember with antennas. And the easiest way to get started with something like easy NEC is to model some antennas that you know something about, or you expect a certain level of performance from that antenna, and then you think you've got things more or less right with the modelling, and you can develop it from there. You can start modelling dipoles, you can start modelling verticals, and then you can move on to beams and quads and receive antennas, beverage antennas, antennas low to the ground. All that sort of thing can be modelled fairly easily with NEC. So, however, we've taken some of the hard work out of this for you, because I've been modelling antennas, as I say, for the last 20 years. I think I've modelled now more than 800 antennas. Now, I haven't actually built 800 antennas, because some of those antennas I've modelled, I've decided that, well, no, that's probably not really going to work for me, or they've been modelled for interest and they've been stored, and I think one day I might drag that out and have a look at it a little bit more closely. I've got particular interest in that field. So it's some of the antennas that I've designed and modelled. These are now becoming available through a column that Steve, VK6VZ, and I write for Radio Communication Magazine, Radcom. And we've been designing some antennas suitable for the magazine, suitable for the UK market, I would say. Small gardens, restricted gardens, restricted height, antennas with low visual impact. The wire antenna works perfectly as a low visual impact antenna. But trying to tweak these antennas so you can get a little bit more gain out of them, a little bit more performance than you would perhaps just a half-wave dipole or vertical. And it's kind of interesting to see what you can do with an antenna, particularly on the HF bands, when you're using the antenna at a higher frequency than what it's really designed for. So you might have a half-wave dipole. If you fed that half-wave dipole in the centre, but you made it one wavelength long, you'd have two halfways in phase. But unfortunately, you wouldn't have much of a match to the 50 ohm coax in the centre. And this is where the whole debate comes in about the matching. If you were to feed that full wave antenna on 20 metres with open wire line, and you made the open wire line a quarter wavelength long, you'd have a pretty good match down the bottom for 50 ohm coax. So there's an example. There's a really simple example of a matching device. Then you might say, well, why do I need two halfways in phase? Well, two halfways in phase is going to give you more gain than a dipole. It's going to give you a greater null on the sides. It's essentially going to be bidirectional. And the gain of a dipole is probably only about 1 dB. It's nothing to get really excited about, but it does give you some gain. And you can extrapolate that a bit further and build antennas that are longer. Again, you can have an antenna that's 2 wavelengths or 3 wavelengths on the design frequency, and that will show some gain. So all of this is revealed when you start modelling in Easy NEC. So one thing that I've found with these modelling programs is that essentially, I would say that my experience is that what I design and what I build, it's about 95% right. You're not going to get anything that's 100% right because there's too many local factors, there's too many trees, there's too many buildings, there's too many uncertainties about what ground you might actually really be on. And that the ground factor does make a difference, and you can program that in, but it's hard sometimes. I mean, I'm up here I'm near the top of a hill, it's rocky ground. I've got a very good location. I've got a great takeoff to Europe and JA. The ground slopes away nicely. Can't really model that into Easy NEC. There are other programs you can use to analyse your location and decide whether or not that the directions you might be getting some extra gain in. Obviously, if you've got a hill in the way, it's not going to work as well. If the ground slopes away, it will work. Any given antenna will work better. I've not had an enormous amount of success here with verticals, but I have had some success with vertically polarised antennas and also cross-polarised antennas where I have a mix of vertical and horizontal polarisation. They've worked fairly well here, particularly on the low bands, particularly on 80 and 160 metres. So it's useful to consider other ways that you can feed and manipulate the antenna with the space that you've got. If you've got a reasonable amount of space and you can run out a wire that's a bit longer, then that can help. If, for instance, the wire is a wavelength on 20 metres, it would make it just a bit over 20 metres long, you can feed that in a off-centre fed fashion. You don't need to put in a 4-to-1 balun. If you have a look in some of the other textbooks, every textbook I've seen has got a 4-to-1 balun in there for an OCF dipole. You don't actually really need that balun. I found with a degree of experimentation with Easy NEC that you could dispense with that if you run 75 ohm coax to the feed point and you carefully select the distance from the end of the antenna to where the feed point is. A small coax choke balun at the feed point is all you really need for 20 metres or 15 or 10 metres. And on 75 with 75 ohm coax, you get a pretty decent match on 20, 15 and 10 metres. And importantly, on 20 metres, well, it just works like a dipole. There might be a little bit of gain. There might be around about 1 dB gain because it is one wavelength. But on 15 and 10, you get a bit more gain, and you get a better match on 15 and 10 as well. And the pattern is really nice. The pattern is a clover leaf on 20 metres, and it's also a bit of a clover leaf with a bit more gain off the ends on 15, and on 10 metres, same thing. It's the lobes start to split up as you go up in frequency on the azimuth plots. But the interesting thing is when you look at the elevation patterns. So on 20 metres, the elevation pattern is typically probably around about 30 degrees, 35 degrees. This is for an antenna that's around about 10 metres high. But then on 15 metres, the elevation pattern lowers down to around about 20 degrees. And on 10 metres, the elevation pattern gets down even a little bit lower. It's down around about 15 or 16 degrees. So that's actually the most useful part on this antenna. You could have a 10 meter antenna. It's not a beam; it's a single wire, and it's giving you a few dBs of gain in a bidirectional pattern over a half-wave dipole. But the important thing is it's giving you that gain at a lower angle than a comparable dipole at the same height. So, and you're getting also a nice bidirectional pattern, but you get, this is on a clover leaf type pattern. So you get basically some gain in 4 directions. It's a little bit asymmetrical. So you've got an antenna that's essentially two wavelengths long on 10 meters, and the maximum gain is in the direction of the wire. Now, this antenna, we've called this the Tri OCF antenna, and this was one of the first antennas that we published in Radio Communication magazine a few months ago. And as I say, this was specifically designed for the UK market, and as such, we kept the height a little bit lower than perhaps you would otherwise, and mindful of the fact that there's a lot of people that don't even have 20 meters of space to get this antenna in. But let's just say you don't have 20 meters. Let's say you only have 15 meters or even 10 meters. You could still fit this in. You could fold down the far end. You could maybe fold down the, you could fold down 10 meters of the length in a vertical fashion. It will still work. It's going to mess the pattern up a bit, but it's still going to work. And I think that's the important thing. Don't get too scared to change the design or the configuration. You can even make this work as an inverted V, and you can make it work as a sloper as well. I've got this antenna configured as a sloper. Now, my circumstance is a little bit different. I originally put this antenna up, this Tri OCF antenna. I put this up as a receive antenna to help me with contests and SO2R activity. And I've got this antenna suspended from a tree. It's around about, it's probably around about 20 meters at the top, and it slopes down to about 10 meters. And it slopes in a sort of a southeasterly direction, I would say. But the antenna still works very well as a sloper. And if I model the sloper, it doesn't, the pattern doesn't change that much. There's a bit of asymmetrical skewing of the pattern towards the lower direction of the sloper, which I would expect. But it's not terrible. And I've found that it's a pretty good receive antenna. It works really well. And the important thing for me, in my circumstances, is that it's located about 100 meters away from my transmit antenna. So it's really useful with some bandpass filters to use that as an SO2R antenna. And I've probably mentioned this antenna in some of my previous podcasts as well. And to kind of prove whether or not this antenna is really working, apart from on receive, quite often I've used it on transmit on an experimental level with just 5 watts of CW and managed to work quite consistently into Europe and the US and JA. Now, bearing in mind I've got a good location, but the antenna is working, and you could take this type of antenna and it would give you a very good performance, at least on 2015 and 10 meters. If you use the internal matching or ATU within your transceiver, you will be able to match it on 17 meters and also 12 meters. And I've even found that this antenna works quite well on 40 meters, which really it shouldn't do. The kind of theory says, well, no, this shouldn't really work that well. But on 40 meters, it's a half wave, but it's only fed 3 meters in from one end. So it's very much it's an OCF. It's an off-center feed. But I've worked stations on 40 meters with this antenna. As a receive antenna, it works really well from 80 meters through to 10 meters. And it's even quite a good receive antenna on 160 meters as well. So with one piece of wire, I've got a number of options, and it's a really simple antenna. It's not complicated at all. And we probably will be republishing this in a book soon to come. So Steve, VK6VZ, and I are working on a book about these antennas, and with a bit more detail, a few more diagrams, and maybe some more photos, going into a little bit more detail about the exact construction. But it's not a difficult antenna to construct. And it's not the purpose of this podcast to tell you how to construct this antenna. But what I would like you to do is think about how you can improve the antennas, the receive and transmit antennas at your location. Because everything you do to improve those antennas will pay dividends. You could go and buy another transceiver. It won't make any difference to your output signal. It may not make really any difference to your receive capabilities. Most modern receivers and transmitters these days are pretty good. I mean, there's obviously some standouts. You can spend an enormous amount of money on a transceiver. But I don't know, you may have heard one of my previous podcasts with E77DX, who went out to D4DX, the Cape Verde Islands, and operated in the CQ Worldwide CW contest. And it looks like he may have broken the standing world record in that contest from that location. Now, Cape Verde Islands, you're DX and you're very much in demand, and it's not necessarily a normal situation that most people can relate to. However, for logistical reasons, which included the weight of his luggage, he went out there and operated with two FT10 transceivers. Now, this is not an expensive transceiver. This is a run-of-the-mill transceiver, a bit like the IC7300. It's not like the top-of-the-line ICOM or the top-of-the-line Yaesu. It's a fairly standard transceiver. And I asked him on the podcast, I said, well, and bearing in mind he was dealing with lots of pile-ups and it was very hectic and he made nearly 10,000 QSOs. I said, well, how did you find the transceiver? Was it adequate? And he said, well, it was more than adequate. So, but he had the advantage of a fantastic location. They've got some brilliant antennas and he's a very good operator. So it's not so much about the equipment you've got. Most of the equipment these days is pretty good. And it's all about those antennas. And this is one antenna, this Tri OCF antenna is a really good antenna to start off with if you've got limited space. Now, you could also build this, if you don't really have any space at all, you could build this for 15 meters instead of for 20, 15 and 10. And you're going to get performance on 15, you get performance on 10, you should get performance on 17 and also 12 meters. And it may even work on 20. You may well be able to get a match on 20. And the pattern on 20 is still quite good. So we live in an era where most of the antennas that you can build with a low impedance feed, whether it's 75 ohms or 50 ohms, will be adequately matched by the antenna tuning unit in your radio. So providing you're doing that, you are in fact sending as much RF to the antenna as you can do. The effect of the SWR doesn't have as much effect as people realise, particularly on the HF bands, and particularly if you don't have a long run of coax. And the coax is reasonable quality. You know, it's RG213 or it's LMR400 or even RG6 has got relatively low loss on the HF bands. Even with an SWR of 2 or 3 to 1, the actual match loss is still greater than the additional loss from SWR. And there's many calculators online. You can go online, have a look at that and prove it for yourself. So don't get too worked up about the SWR. Think more about the antenna, think more about the pattern, think more about the DX effectiveness if that's what you want to do. One other point about these antennas as well is I've pretty well switched over in the last 3 to 4 years to using 2mm diameter stranded electric fence wire. And this has some really nice advantages over copper. Copper's heavy, so if you've got a long span with copper, you may have some problems because it can really sag and be heavy and you need more tension. The aluminium electric fence wire is very light. It's a little bit springy, but once you get some tension on it, it's absolutely fine. It's easy to work with. It can be easily terminated with crimps, and I use nickel-plated crimps, and I use crimping tools, and then I make sure, as far as possible, that the crimp is insulated. You know, I use some self-amalgamating rubber-based tape, and then I over-tape with PVC tape on top of that. Look, in 3 years, building a variety of antennas, such as spider beams, the current antennas I've got at the moment, which are stacked X-beams, X-beams for the low bands, 160mm dipole, 80mm dipoles, all my receive antennas. I've had no problems with corrosion between the aluminium wire and the nickel-plated conductors. The aluminium wire is sort of, I would describe it as being semi-drawn. And it's got, I don't quite know exactly what they've done with the aluminium, but the fact that it's electric fence wire seems to help a little bit. It seems a little bit harder than normal aluminium. So I can really recommend this stuff. You can pick it up quite cheaply. It's a fraction of the price effectively compared to copper. And there's no detriment in performance by using this 2mm diameter stranded electric fence wire. So I can recommend that. As with most wire antennas, you can reuse the wire. You can do something else with it. You can, if you don't like the antenna, you can rip it down and start all over again and look at one of my other designs. So we will be, as I say, Steve and I, VK6LW and I will be publishing a book at some point. We're just getting some of the information and material together. Some of the ideas that we've got suit more of an international audience because of the space required. The antenna what I'm describing right now is really something that's probably a bit of a space-saving antenna. But some of the other antennas that I've built are a little bit bigger because I've got more space here. I can do a little bit more experimentation. And I do like to try and test out these antennas before we think about publishing anything so that I can get a feel for how they are on the air. And as I say, mostly with Easy NEC, with the help of Easy NEC, most of what I build, I'm pretty happy with the results that I get and I see. And I feel I can trust that program to help me design these antennas. But you can have a look at the program. It's a free download. There's no restrictions on it at all. You can download it for free, play around with it, have a look, see what you can do. These podcasts and these articles that we're publishing, really the aim is to try and inspire you to build your own antennas, which is what I've been doing for the last 50 years. And I've really enjoyed it, and I intend to continue on with that journey. So that pretty well wraps up this podcast for now. If you've got any queries or questions or anything like that about these antennas, you can always email me. You can email through to vk6lw.kev@gmail.com. You can find me on qrz.com. You'll also find me on the bands as VK6T in contests. So I'm a reasonably active contester. And we will be publishing, as I say, a book, and there will be some more podcasts to come fairly shortly, actually. Now I've started this series of podcasts, I'll be moving on to some of the other antennas that we've designed and published so far in the magazine, and we shall progress from there. So 73 is from now. Thanks for listening, and look forward to bringing you the next podcast shortly.